Today we're diving into the world of dairy farming, but probably not in the way you're thinking. We're going to look at how some really cutting-edge data science and AI are being used to unlock the true potential hidden inside every single cow. So this is really the central question, isn't it? A farmer sees how much milk a cow produces each day. But is that number the whole story? Or is there this hidden, maybe even higher, potential that's just being masked by all the day-to-day stuff that happens on a farm? Okay, take a look at this. What you're seeing here is the raw reality. Every single one of those little black dots is a day's milk yield. And as you can see, it's kind of all over the place. That's what we call noise in the data. The colored lines, well, those are different mathematical models, all trying to cut through that noise to find the real story, the true pattern underneath. The challenge is, which line is actually getting it right?
To figure that out, we first have to get on the same page about a couple of basic concepts. We're essentially trying to create a kind of performance forecast for each cow, right? We want to separate what she could do in a perfect world from what she actually does on any given day.
So the foundation for all this is something called a lactation curve. It's basically the natural rhythm of milk production for a cow. It rises after she has a calf, it hits a peak, and then it slowly, gradually declines. Yeah, you can totally think of it as her ideal performance forecast for the whole season.
But, life happens. And for a cow, that means things called perturbations. The source material talks about these as these temporary dips in milk production. They can be caused by anything, really. Health issues, heat stress, even just the stress of being moved to a new barn. They're literally the unexpected sick days that just throw that whole forecast off track.
And here is the absolute crux of the problem. When you use all the data points, including those sick days, to try and draw that lactation curve, the whole curve gets dragged down. It gives you this pessimistic, kind of watered-down view of the cow's actual ability. It makes it almost impossible to know her true, unbothered potential. So how do you fix this? How do you tell a model to just ignore the sick days and see the real potential? Well, that brings us to a really cool tech showdown between the old way of doing things and a brand new AI-powered approach. So in one corner, you have the previous models. The paper talks about a couple of them, but they tend to be really slow, computationally expensive, and sometimes they can be super unstable, creating these weird, unrealistic curves. And in the other corner, we have the new challenger, an unsupervised machine learning model, or ULLM for short. It's built to be fast, tough, and to let the data itself point out what's weird.
The way this UMLM works is actually pretty brilliant. First, it just draws a simple curve through all the data, the messy parts and everything. Then, it looks at the gap between that curve and the real data points for each day. The AI is smart enough to recognize that those big temporary drops are the outliers, those are the sick days. So it flags them, kicks them out of the calculation, and then draws a brand new, cleaner, and way more optimistic curve using only the healthy days.
Okay, so it sounds great in theory, but does it actually work any better? To find out, the researchers ran a big simulation. They basically created 1,000 artificial cow records, and they purposefully put in a specific number of sick days, just to see which model was the best at finding them. And the results are pretty telling. The first model, PLM, has great sensitivity, meaning it catches most of the sick days, but its precision is awful. It's like an alarm that goes off all the time. The second one, IWM, is a bit more balanced, but then you get to the new AI model, the ULLM. It hits this incredible sweet spot with the highest precision of the bunch while still being really good at catching the real issues. If you really want to see the overall winner, you look at what's called the F1 score. It's just a way to balance out precision and sensitivity into one number. And, this chart just says it all, doesn't it? The ULM clearly comes out on top. It's just got the best balance of finding the real problems without crying wolf.
Hey, don't just take my word for it. The researchers themselves put it perfectly. They concluded that the AI model's higher F1 score showed a more balanced adjustment and improved perturbation detection performance. In the lab, it was the undeniable champion.
All right, so it works in a clean simulation, but the real test, the one that really matters, is what happens when you throw messy, real-world data at it from an actual farm. The researchers took over 2,800 lactation records for more than 1,600 real cows. Let's see what happened.
This slide right here is incredibly revealing. Let's just focus on one cow. On the right, you see the curve from the older IWM model. See how it gets all weird and flat and distorted at the beginning? It just doesn't look natural. Now look at the left. That's the new ULMLM model for the exact same cow.
The curve is smooth, it's stable, and it looks just like what a natural lactation curve is supposed to look like. It's the perfect picture of stability versus instability.
So what was the bottom line impact? Well, by filtering out all those sick days, the UMLM estimated that the cow's true potential was on average about 2.4% higher over a full season. And the key thing here, something the study points out, is that this is a plausible and reasonable adjustment. It's not some wild fantasy number, it's a realistic estimate of what a truly healthy herd could achieve. So, okay, we've got a better model, it gives us a more accurate number, but so what? Why does this really truly matter? Well, this is where the tech goes from being just a cool graph to a seriously powerful tool for building a smarter future for farming. Because the model is so good at spotting those sick days, it can show farmers exactly when their cows are the most vulnerable. This chart shows when it detected those perturbations. And look at that, there are these really clear peaks, one right after birth and another big one around day 60, which is right before peak milk production, a time of huge metabolic stress for the animal. I mean, this is data you can act on. And the implications of that are just huge. With this much clearer picture, farmers can make way more accurate feeding and breeding plans based on a cow's true potential, not her bad days. The model basically acts as an early warning system for health issues. You can even start to identify which cows are just naturally tougher and more resilient. And all of this, it leads to better animal welfare and, of course, a more profitable farm.
So at the end of the day, the really crucial takeaway is this. This was never just about making a prettier line on a chart. It's about fundamentally changing how we see and understand an animal's life. It's about using data to get a clearer, more honest picture of her health and her true, unlocked potential. Which kind of leaves us with one last big thought. This is just one application for one industry. It really makes you wonder, in a world that is just full of noisy data, what other hidden potentials are just sitting there, waiting for us to uncover them? What happens next when we finally let the data tell its full story?